So here is the agenda for today's webinar. It's smartphones, smart apps, and smarter test. Why this topic? And predicting prediction from the horse mouth. So this is more about what is the future of machine learning, uh, where machine learning is heading to, and so what are the emerging parts, and why all this mattered to us, and that's another discussion we would be having as a part of the seminar or webinar, where we'll be connecting the various systems, where the next gen systems sit in between the actual systems that we use in day to day. And next we'll be focusing on the differences between rule based intelligence versus machine learning. So in the past, it was all about an input and you see an output, and then the systems were built intelligently or to behave intelligently by a lot of rules which are embedded into the system. And now it is more of thought process based systems, which is nothing but machine learning. So we'll be discussing more on that. And the next is what kind of tests, I mean, why we need smarter tests here. So what kind of tests can help in testing these machine learning algorithms. And the last is what is the better strategy to test these systems and ensure that we are able to ensure that everything works as per the business intent. Um, before we get introduced further, before we get into further into all these topics, we'll have some examples, and also we'll be discussing more on the Gartner's 2016 report titled "Hype Cycle for Emerging Technologies," which will give you the future of machine learning. So here is the next subset where smartphones, smart apps, and smart tests. I mean, why this particular topic is picked. Smartphones and other devices and mobile apps are already helping to capture the customer behavior and attitudes. In the retail world, I just thought of giving this example based on my familiarity or my experience in the past with retail systems. Uh, so when a user searches for a product and he adds the product to the bag, and he doesn't proceed any further, and if the user is repeating the same, you'll be able to understand by collecting various metrics behind the scene, like what kind of an user the particular user is. And if it is not happening very often, the same kind of behavior, maybe the retail system can intelligently provide some offers using which the user can purchase and move forward. So the systems are helping in capturing the user behavior and attitude, which will help the companies to react based on the user behavior here. And current smartphones are already using machine learning and natural language question answering, artificial intelligence. And I think you would have seen a lot of examples on Siri, Cortana, Alexa, Viv, and Google Photo sorting app. So let me give you an example of Siri here. So if I mean while I was browsing, or rather exploring more on how how best the systems are in learning world, Siri was one of the example where I found that you can play a song, and Siri will be able to find from what is this album all about. You can ask Siri a question like what from where this song is coming up. It would give you the details of the album. Similarly, Google Photo Share. I had an experience a couple of days back where it showed me up an option by listing all the photos of one of my family members, saying like, "Can you tag a person's name to all these photographs?" So the Google apps or Google Photo Sharing app was able to collect information. Excuse me, I'm just muting one of the attendees. I think, yeah, He's on mute. Sorry. So Google's photo sorting app was able to group all these photos and ask the end user to tag it to a particular name. So when you look at these photos are ranging from anywhere like 10 to 15 years old, and Google was able to rightly identify the people appearing on various photographs, and it was providing input. I mean, like, these are all of same category, can you group it, kind of. And off late, based on occasions, you are provided with suggestions like, can you group these photographs based on a Christmas or a birthday, kind of. So I mean, how is this built? It's built based on a lot of analytics around your information that is shared by you. And and uh, and machine learning is not completely evolved. So there's a lot of exploration or the invention that is going on in this particular space. Let me take an example of Siri. The same example is about I play a song and I was able to identify an album. So the similar example, I applied it on a different thing, where I played a song from a particular film, and I was asking Siri to find from which film is this particular song. It was not able to relate. So the current machine learning is only up to a particular extent, and there is a lot of invention going on around this space to expand beyond. So machine learning is still evolving, and the next is there are a lot of algorithms. I mean, I was browsing GitHub a couple of days back. I learned that there were about 37,000 GitHub repositories on machine learning, and within like 12 hours span, I was able to see like 200 plus repositories newly added to GitHub. So that's the space at which the machine learning is evolving. And the commonly used algorithms are TensorFlow from Google, Curie from Apple, um, Torch, Theano, and H2O. So Torch, Theano, and Torch/Theano are companies which are on the same name, and H2O is H2O.ai, which is another artificial intelligence company. So next, with artificial intelligence is a subset which provides the inputs to the digital space for a better user experience. So now moving further on a few of the examples. So until until now, the topic was more around how the machine learning can be used in digital space. Further down, the machine learning has more responsibility in terms of social, environmental, public health, and economics as well. So, Carnegie Mellon University and the colleagues from the university implemented an algorithm which can predict heart rate at 80% accuracy within before 4 hours of the actual attack. So they were able to identify a set of patients who were about to get a heart attack 4 hours in advance, and a person named Raid Ghani from University of Chicago helped in identifying the risk from police officers, which was reduced by I mean, which had correctness of about 12%, and it was reduced for incorrect records by one third. So I would like to explain the situation here, like where the police officers are working for prolonged hours, and if they are working beyond that limit, they per se they are working for 12 to 14 hours a day, and if they work beyond, they are risk to the there could be risk to the society because of their fatigueness. So this fatigueness is actually identified by Raid Ghani's algorithm from University of Chicago. So it had its own benefits from a social standpoint. Chicago's Department of Health was able to diagnose the lead levels from bodies of the various children, and they were the machine learning algorithms helped in reducing the poisoning of the children from Chicago. And last one is Microsoft teaming up with the government of Andhra Pradesh in India, which would help in identifying the right time to sow seeds so that it can improve the agriculture aspects. So, not just with the digital, there are a lot more examples like this where machine learning is beyond user interface, ease of use, more of information. Beyond that, it has more of a social environment, public health benefits as well. So that's where machine learnings are used. Machine learning and artificial intelligence is used right now. So predicting the prediction from the horse mouth. This is where we have the latest Gartner's report, which provides details of what is the future of the technology. Uh, so, uh, so here it shows in next 2 to 5 years, machine learning, natural language question answering, and software-defined systems would be the trend for next 2 to 5 years. So, as I said, like there are a lot of inventions happening around this area. So I could give one example where Siri has been advanced in the name of Viv by the founder of Siri, where they are looking beyond just natural language question answering, and not just searching the web and returning the input, rather manipulate all the data in a mathematical form and represent back. So there was one example like Viv was asked, "What is it weather like 3 weeks before or 3 Thursdays before?" It was able to calculate like 3 weeks before and a Thursday, and it was able to respond. And Viv was phenomenal in giving another example when a question was asked like, "Will it be very hotter or beyond 70 degrees after 3 days after 5 p.m.?" So it was able to calculate the exact days and say, give a prediction saying that it would be hot or not. So that's how the systems are evolving. Um, so now moving on to the next slide, why all this matter to us? So as we were discussing, machine learning, artificial intelligence, and NLQA is just a subset of a larger system where we have other systems around it, like digital, big data, and data sources, which combined together are providing rich user interface to the end customers or end users. So the lower portion is the data sources. So yeah, so the data sources are geolocation data or sensor data. It can be from your car, your home systems, or your social network, your search, your post, Pinterest, Tumblr, or tweets. It can be anything. So this information is passed on to big data, and big data analyzes this data and pass it on to machine learning, artificial intelligence, and NLQA systems, where this data is analyzed, grouped, and there is a model that is brought out, and that model would apply further on the data, and that information is passed on to the SMAC, where the current digital, so social, mobility, analytics, and cloud. So let's take a few of the examples on your LinkedIn or Facebook, giving you some options or some of your interests. Are all these brought based on various data sources, which has provided information to big data, which is further processed by ML and then passed on to the digital platform. So next, we would be focusing on rule-based intelligence versus machine learning. So as I was discussing initially, so there was always an input and an output. Later, there came some intelligent systems which are defined based on rules. I would like to give you a couple of examples here. So with respect to rule-based system, let's say a larger retailer is opening a store in a different portion of a city, and there's a rule that is applied saying that 10% of every item can be passed on to the new store, and there is a huge demand in the new store, and the 10% is not enough. So the rule system will be able to provide only certain amount of stock for the new store. Rather, when there is a higher demand, there is a lower stock, or vice versa, there is a higher stock and low demand. So the system will not be able to adapt based on business conditions when it is a rule-based system, because these rules are modified on a periodic manner, and there could be a potential loss in the business. And similarly, let's consider a healthcare system where a particular doctor has submitted his claim for 100 patients for a month, for the first month, and it's valid as per the system. And in the second month, there was a huge outbreak of flu, and he was submitting 105 cases. The insurance company starts rejecting these claims, stating that an average physician can only look at 100 claims per day. So now it is all rule based, because of which these 5 claims are rejected, and there is a hassle of discussion between the insurance company and the doctor or provider in discussing about these 5 claims. If it was implemented in a real time NXG system, which is machine learning, artificial intelligence, or NLQA kind of systems, what would happen is, like, the retail, in the first case, the retail, there would be information collected from various sources like social network, news, or any post that you make across social network, identifying that there is a huge demand or a weak need of various products from that particular store, and the rules are adjusted, or rather the stock is adjusted accordingly. In the second case, the doctor who has claimed, who has put a submission for 105 patients in place of 100, the machine learning can understand that there was a huge outbreak, because of which there were larger claims here. That can be understood by collecting various data from various sources. So now let's discuss further down what is a rule-based intelligence system and NXG system. So rule-based system works based on inference engine. So inference engine is something that manipulates data against the rules. So for example, you have an input EA, from the user interface, it goes via data channel. It can either be a service or a direct call to the inference engine. So the inference engine will pick up the various rules, apply it in a nested manner. So let's say that there are 10 different rules which are applied on each of the data. So it is applied in a nested manner on the database, and then the output is passed on to the user interface. So due to which you'll be able to get an output which is already predicted. And now, with respect to next gen systems, the information is collected. Just a minute, I'm sorry. I saw someone came on mute. So, in case of next gen systems, the first piece is the training. So, where the data is collected from various sources. It's either text or images or the files. So this data is split into something like learning data set and actual data set, and there is a feature vector that learns first based on the input that is provided and tests on its own, and it makes a model, and that is actually the machine learning component on which, when you apply data, it would give you an output based on the events surrounding the data. So which would be a real time change. So the machine learning will always think just like human, based on various conditions around the situation. So just in case of the clinical example or a retail example, the machine learning will adapt based on the situation. So that's how the rule-based system is different from a next-gen system. So further, I want to bring a detailed example of LinkedIn, Facebook, and Twitter, where you would, I'm sure most of you would be using these features, like people you may know, news recommendations, job recommendations. So now, if these features were implemented by a rule-based system and NXG systems, how these features would have been implemented. So for the first case, for people you may know, in a rule-based system, it would have been defined based on your mutual or a second or third level contacts, same college, school, university. Based on certain rules, you would be shown with people you may know. But in case of next-gen systems, the systems are built in such a way that, let's say I go search for a particular topic. Now, uh, the the systems like LinkedIn, Facebook, or Twitter will provide the people you may know based on my interests. Basically, this would help me to mingle with people of similar interests and similar thoughts. And the second one is news recommendation. So the rule-based system picks the data from my profile typically and provide me with information, something like location, profession, age group, etc. So based on these factors, it would provide information. But in case of NXG system, it would it would provide based on my interests or my searches in social networks or my Google searches in the past or whatnot. The various information based on my interests, it's collected, and the recommended news is just based on my behavior on social network or the external world. And job recommendation is another thing. So in case of rule based system, it would provide based on your current and past, or maybe a slight future based on your next level of job. But in NXG, it would focus more on growth path for you or future technology and all these based on which the jobs are recommended. So it makes a lot of difference between rule-based system and NXG system. NXG thinks more like a human being. Rule-based is more of a hierarchy. Like, I mean, I follow a step of a set of rules, and I get the information kind of. So it makes a lot of difference between rule-based and NXG. And in case of rule-based system, you can easily test because you know the conditions of each and every data that needs to be tested. So finding a matching record according to the rules. So for example, when I go search for a particular name, and if I'm able to find a second level contact, it either means that he is from my school or a college or a second level contact. And when I'm validating all this, I can modify the preconditions and post conditions, ensure that I'm able to get the required output. So it's all rule based. So it's a lot easier by creating a lot of data sets. And let's take the same example of the doctor. You can create 100 claims and see if it works, 105 claims and it works, and so on. So rule based system, it's all predefined by applying nth level of rules, and you can ensure that you are able to get an output, or you can test at the same time. In next gen systems, you'll not be able to test it in a similar. Now the question is, how are we going to test it? So here comes the smarter strategy. So it's not that we'll be able to test just the program with respect to next generation system. It starts with the data. So the first portion is the big data. The next is NXG system, and then the digital. So with respect to big data, so the data transfer, the data processing, testing for data processing is the first part, and data validation and performance testing. These three are the primary portions of big data testing, where batch, real time, and interactive, you test it with various forms. Like batch, you collect a set of forms, and you process it, or set of or a data collection and process it, and see whether the output is as required. The second one is real time, where you give an input and you get a response. You predict whether there is a relative data based on the search or the input that's given. And interactive is more of, you give an input, you get an output. Based on the output that you receive, you further give another input, and you validate whether there is a right interaction that's happening between the big data system and your stub. And the next is data validation, where the data stage validation. So where you'll be validating the source, the data that is collected from various sources. And map reduction, where there's a lot of processing in data in by where there's a logical sequence that's brought, and you can process it further. So you would be validating data just before passing it on to the next generation systems. And output validation, the right format, data type, that is being passed on to the next gen system is validated here. Performance testing, it's all about how quickly the data is getting processed. So that's where you have data ingestion throughout, data processing, subcomponent performance, and so on. So big data is another vast region. I think it has evolved quite a bit. So which can be done in an easier way, and there are at least a minimal level of tools which can be used. And in the past, I myself have built a framework where big data can be tested using one of the open source tools. So I think it's a regular kind of data testing here. With respect to next generation system, that's where we have the challenge here. So can I test a next generation system as a huge? Is a bigger question. So it's better to focus on a unit level. The first focus is on objective of the method. The second one is correctness. All these are mathematical models. We need to try with different inputs and see whether the various outputs which are received are within the statistical limits, like mean, median, and mode. So that's one way of testing at a unit testing level. Next is on accuracy check. So it is generally advised that you get 10 data sets. You train the system with 8 data sets and test with 2. And you need to keep trying with various. That's where you get into split test, multiple split tests, cross validation, multiple cross validation. And then, as I said, like statistical significance test is all about mean, median, mode on these tests. That's how you can check the accuracy of the output. And data check, this is one critical area which we need to focus on. So data leakage is more of there is a dependency with a data source, and we are not able to access that particular data source because it's private. So which means that there is a leak in data, or I'm not able to access the entire information to uh, process the data and provide it to the next level systems. The next is overfitting. Means either there is too much of information in one set of data, and the other doesn't have so much. Data sampling and splitting. So when you're grouping data, it should be ensured that there is no relevance between data set 1 and 2. So if there is a relation, there would be a lot of confusions in processing this data. And data quality. So it's more about whether I'm getting the right source, whether the data is seeded in and passed to me. Is it correct? Will it spoil my system based on data? Just take the same example, like if there is a lot of seeded in data, my output or my predictions would always be negative in the real world. So data quality is one of the important aspects of next generation systems. And now moving on to digital. So digital is the outmost thing that we see on a day to day. So digital portion can be anything. It can be an app or a phone or a firmware, just like Siri or Cortana or Viv or whatnot. So the first point here is APIs. So if you browse through Google for machine learning or natural language question answering or artificial intelligence, you will read through many of the you read to the terms called machine learning APIs. So API is a outer shell which would call these machine learning algorithms, will provide you an output. So which means that the APIs should be tested in such a way that they can be compatibly passed on to the digital systems, and they can be used in a right way by the digital systems, and push it to the UI. That's where we need to do a lot of system functional and unit testing from an API standpoint. And then mobility, as you know, like you'll be testing more on um, um, from a UI standpoint, more of functional regression or component level testing. And with respect to web apps, you can look for assets. One of the solution that we have provided some time back is validating page assets for web apps on both desktop and mobile. It is available in GitHub in Zuci. So the web apps assets are validated. You can tell whether the assets are too huge or too less, and how the data is represented in social share, and how the promotions are consumed, marketing, etc. All these needs to be tested, and tests performed are typical functional performance and security and cross-platform here. And last but not least, so far we have talked about the digital world, how it works, or digital systems, how they are useful for the end user. I may not have mentioned here, just to bring it as a highlighting point here to discuss more. So there is something called analytics, where it can be either Google Analytics or Core Metrics or so all these analytics are some source of information for the next generation system. So a cluster of analytics are provided to big data, and that big data is going to pass the information to next generation system, which would in turn reprocess and give you as a feedback to the digital system. So we should ensure that all the analytics are rightly tested and captured, and they are, which would in turn help for improvement of digital system. So these are the various aspects of machine learning, and as the topic tells, smartphones, smart apps call for smarter tests. These where we have discussed more on the apps, phones, and how we can test them. So um, we are ending with respect to the webinar, and so you can reach us on LinkedIn, linkedin.com Zuci Systems, and Facebook we have our page Zuci Systems, and Twitter you can contact us, or you can email us on solutions@zucisystems.com for any questions if you have. And you can please follow us on LinkedIn pages and Facebook pages. We are providing more solutions and utilities, and we are actually working on a couple of utilities for machine learning and natural language question answering. So these are our next areas of focus to provide a solution for the testing world. Thank you all for being part of this webinar. And if you have any questions, I'm here to look at the chat and answer to you. I have not heard any questions. So I would upload this webinar content on SlideShare. So one minute. Sorry, before I wind up, I have a question from one of the attendees here. So here is a question. So why did you connect machine learning, artificial intelligence to digital? So machine learning and artificial intelligence are basically backend systems which would provide input for the digital world. So digital world can be like your social, your mobile, analytics, or cloud. So I can call it more of a logic layer in term for machine learning and artificial intelligence, and digital as a presentation layer in real world terms. So that's why I have connected here machine learning, artificial intelligence with digital. I have another question from one of the attendees. Can tools like Selenium be useful for machine learning or artificial intelligence automation? Thanks for this question. So we are actually working on a product called Auto Explore, which we are working right now, where you don't have to focus much on or you rather do not have to focus on test cases at all, at test scripts at all. So if you provide the URL, the tool will traverse through across the pages, and it will give you um, uh, the output of the exploration that it has done, which means that it has covered the entire testing. So if you ask, yes, from a UI standpoint, Selenium is helpful, but from a machine learning and artificial intelligence, the basic algorithm standpoint, we need to look at writing the supporting algorithms in programming language like R, where let's say there are a set of algorithms decided in machine learning based on the faster processing, accuracy, and various factors. Let's say you pick two algorithms. So, algorithm A is used for development. You can pick the algorithm B or another algorithm and see if you are able to match the output from a machine learning with at least 70 to 80% from a testing standpoint. That would give you a larger scope whether you are heading in the right direction from a testing standpoint for machine learning. And there is another question from one of the attendees. What knowledge should testers have to test machine learning systems? Are functional testers qualified to test them? Machine learning is more about data and predictions, basically. So I think we would have gone through a lot of KNN or ANN, artificial neural networks, in the past during our computer science papers, or statistical models with respect to mathematics. Anyone who has a flair for these areas, irrespective of functional tester or a non-functional tester, will be able to do testing. It's a bit of learning curve. Yeah, they'll be able to test. Thanks for a lot of questions here, and I think I hope I was able to answer a lot of your questions. Can you talk about unit testing from development in these systems? Um, yes. So, so unit testing in a typical world, what happens is like you stub the method with some input and see what the expected output is. Rather, the focus should be on the actual code by the unit tester, where where the model is rightly defined. So, and the second is the intent of the method should also be done. Do we have any frameworks? As I said, like R is one of the programming languages which is of a lot of focus in testing these um, algorithms. So I would say, I mean, this is how it looks like at this point of time for unit testing. There is a lot more questions. Thank you all. Are you planning testing solutions from Shuchi for machine learning and artificial intelligence? Is there a cost associated with them? Um, so cost, I'm not able to. I mean, cost is something that we need to look at and see. But we are building a huge team who can focus on mathematical models and our programming language. We are doing a mixed match of people who are who are experts in mathematics, statistical models. That's how we are looking for people, and at the same time, we are looking for programmers who are adaptable. So we wanted to do a pairing here, where a mathematical person would come up with ideas on statistics and give that as an input for the programmer. So that way, we are already in process of building some testing solutions for machine learning and artificial intelligence. On the cost, we may answer, because we have to look at how the tool set would look like, or dependencies would look like. So far, it is like zero cost, considering R as a programming language. Um, it's a zero cost at this point of time. Any further questions? Okay, I did not hear any further questions here. Thanks a lot for for being part of this webinar, and thanks a lot for a lot of questions. And we'll be sharing this presentation as a part of SlideShare in few days. And if you have any questions, you can even comment on SlideShare, or you can text me, and we'll take this forward. Thank you all. Have a nice day.